Hey students, in this video I'm going to do the review for Unit 3 and it's going to be about absolute value functions. So one topic we reviewed in Unit 3 was about the attributes of absolute value functions. They're very similar to quadratic functions, so we just have to identify where they are. So the vertex, we said the vertex was this turning point on the function, so we just need to identify what the order pair for that is. 0, 0 is here, so we go 1, 2, 3, 4, 1, 2. So we go 4 to the right, down 2. So that's 4, negative 2. AOS stands for axis of symmetry, and axis of symmetry is the line of symmetry that we graph, cutting the, not the parabola, the function in half. So we draw a vertical line going through the vertex. And any vertical line will always start with x equals a number. So in this case, our axis of symmetry will be x equals, and it goes through x equals 4. That's the axis of symmetry. Next, we have the x-intercepts. This specific function graph right here seems to not have any x-intercepts, as it's not touching the x-axis at all. So we can just say no x-intercepts. Y-intercept, this graph is touching on the y-intercept right here, the y-axis. So we just gotta count 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So it's also a point, so we gotta graph it at 0, negative 6. For the domain, we need to remember domain is x, which is looking at the graph left to right. We talked about this graph having arrows as it keeps going, unless it's specified that it's not. So in this case, because it's going to the left and right forever, we're going to say that it is negative infinity, comma, positive infinity. And we're going to put parentheses on the sides saying that it's approaching infinity, but never stopping. This is also known as all real numbers. And if for some reason this needs to be written with notations of inequalities, we're going to write negative infinity less than x less than infinity, as negative infinity is your minimum. Sorry, we don't need parentheses. And positive infinity is your maximum. So the same domain can be written in different methods, different ways. For the range, we're looking at the range of the graph going up and down. So the highest value that this graph goes according to the y-axis is negative 2. 0, 0 is right here. Negative 2 is right here. So that's the max. And below that, it just keeps going forever. So we're always going to write it as minimum, comma, maximum. And minimum will be your lowest, which is negative infinity, comma, the maximum will be negative 2. It is touching a negative 2, so we're going to write a bracket and then a parentheses for infinity. Another way to write this is by just simply saying that we are looking at any value below negative 2. So we're going to write as y less than or equal to negative 2. So this will be the inequality notation of the range. Okay, so you can pause the video and try this example on your paper. All right, let's continue on this next example. So here it's asking you to determine the equation of the function given the graph and then state the domain and range. So we talked about the equation of the function looking at the vertex and looking for another point. The function for the absolute value will always follow the a absolute value of x minus h plus k, that format. B usually goes in here as well in the input. However, when we are writing the equation, we just focus on the A. H and K is your vertex. So if you can find your vertex, that will be the values that you're going to use in H and K. So at this point, the vertex is down here. And we can say that the vertex is 1, 2, 3, 4, positive 4, and then down negative 5. So we have 4, negative 5 as our vertex, which means that in our equation, we're going to have absolute value of x minus our h value, which is 4, close the absolute value, and then minus 5 on the side. The a value is calculated by looking from one point to another. On the parent function, we have 1-to-1 ratio. On this one, we have 1, 2, 3, 1. So raise 3, run 1. So it's going to be an a value of 3. So it's kind of like a slope. We talk about the steepness of a line on letter A. So this will be the equation for this graph. As far as the domain goes, we have arrows on the ends. So again, just like the example above, left and right, this is going forever. So negative infinity, positive infinity, parentheses on the sides, because it's never stopping. And then we can also write R for all real numbers. Range, we're looking at it going up and down. So up and down, the minimum will be below, the maximum above. In this graph, the lowest that is going is negative 5, so this will be your minimum. And then the highest is going is infinity because it has arrows. So if we write this notation as minimum comma maximum, we're looking at minimum of negative 5 comma infinity. We put a bracket on the number because it is stopping and touching at negative 5, and then parentheses at infinity because it's going forever. The other way we can write the range for this is by stating that we are looking at values that are higher than negative 5. So we can write it as y is greater than or equal to negative 5. Okay, go ahead and try this next example on your paper. You can pause the video if you like. All right, let's try this next part of the review. Here you are being asked to describe a transformation. They are giving you the parent function and you are being asked to describe what happened to it. So in class, I did teach you what each one of these numbers do separately. And just to review that, I'm going to just write this down. A value, x minus h plus k. This is the template of transformations. A technically describes a vertical change, whether it vertically stretched or compressed. And then it also tells you if it reflected over the x-axis. So if you have a negative a value, that negative represents a reflection. X-axis, sorry. And then the h value, we talked about these being the vertex, these two letters. So h being the x value represents left and right, so how it shifts left and right. And then the k is the y value, so that represents how it shifts up and down. So just by looking at these values, 5, negative 4, and 3, I can tell you that we can sketch that this graph is going to have a vertex when x is 4, and when the 3 is the y value, which is y. So the vertex for this will most likely be 4, comma 3. 4 to the right, 3 up. The fact that the a value is positive, that means it's going to be opening up. So we just need to kind of compare how this looks compared to the parent function. If the a value is greater than 1, it will become thinner. It will become narrower. So that will be a vertical stretch. If the a value is between 0 and 1, then it will be a compression. It's going to become super wide. So again, these are just facts that were discovered throughout the unit, but you can always use your calculator and graph. So if I graph, I'm going to graph the parent function, so the absolute value of x. And then I'm also going to graph the equation they give me, so 5 absolute value of x minus 4 plus 3. And as you noticed, it follows the sketch I kind of have right here, where it did move to the right and up and it just becomes thinner. So our transformations here were that it shifted to the right, and we can go by based on the H value right here, right, and then up. So shifts right 4 units, left, no, I'm sorry, up 3 units, and it is vertically stretched by 5. Okay, so those are the 3 descriptions. Right 4 units, up 3 units, and vertically stretched by 5. Okay, so pause the video and try this example. Here is the template again of the transformations. All right, so let's try this next one. We are going to compare this parent function to this notation right here. And if we go by the notations here, this one does not have an A value. This one has a B value. So we're going to talk about this one separately and say if the A value is negative and there's a B value and an H value and the K, what's going to happen? So that negative in the front, we said that was going to be a reflection over X. That means that it's going to look down. It's going to flip it. If the B value is going to be there, we're going to talk this as a horizontal change, either a stretch or compression. Following the same example as A, if A was greater than 1, it became thinner. Same thing with B. If B is greater than 1, it becomes thinner. So we can say that it is a compression because we're making it thinner. We're making it, if we want it wider, we want it to be between 0 and 1. And the description for that will be a horizontal stretch. H and K, the fact that this is X, sorry, this should be X minus H, and this is saying X plus 6, then we need to interpret this as X minus a number that will make it be plus 6, so that will be a negative 6. By having a double negative here, it tells you that this is going to go left. And once again, to memorize that, use the opposite of what you have here. That's plus 6, that means it's going left. If this is minus 1 on the K though, that is for sure going down. So these are the descriptions just by looking at the facts. You can always graph it just to double check. So let's graph it here. I'm going to leave the parent function from the previous one, and now I'm going to type the negative absolute value of 1/2 and then X plus 6 and minus 1. Okay, so according to the predictions we had here, it was going to reflect, so it reflected. We said that it was going to be a value between 0 and 1, so it was going to make it wider. So the description for that is that it horizontally stretched. As you can see, this became wider. That 6 made it go to the left and then down 1. So all the descriptions that are predicted here could be found with practice, but you can always use the calculator to verify. So we're going to write that it reflected over the x-axis, and that negative right here showed you that. The 1/2 showed you that it horizontally stretched. And then the scale factor of the B value you're always going to do 1 over b as the scale factor. So in this case, we're going to do 1 over 1/2, which if you separate this division is 1 divided by 1/2. So if you type it in the calculator, if you do it by hand, you're going to end up with the answer, which is a whole number. So 2. That's what we get. That means that the scale factor is 2. On the next part, we shifted left 6 units and down 1 unit. And again, if you wanted to just sketch that, it is down here. It is really wide and reflected. All right, so try this next example. And then now let's go ahead and continue in the back. So here we're gonna be solving equations of absolute values. We talked about how when we solve equations, the first thing you want to do is isolate for that absolute value. And then in class, I advise you to treat this as a variable for now. So if this was 1/2 x plus 3 equals 10, we will need to leave this alone. And this is connected to that. So we are going to take care of the 3 first. We're going to do inverse operations to get rid of this. So minus 3 on both sides. And we have 1/2 absolute value of x minus 4 equals 7. After this, after we remove the 3, we're going to have 1/2 x equals 7. So how could we get rid of 1/2? Most of you like to just keep going with the practice of dividing by the coefficient, so that's fine. We can divide by 1/2. You can also multiply by the reciprocal, so you can also have a multiplication of 2 to get rid of that. In this case, I'm going to just divide, since most of you are doing that in class. And when I type this in the calculator, make sure you type it correctly. 7 divided by 1/2. It gives you 14, which again confirms the whole process of multiplying times the reciprocal. If we multiply this times 2, we will multiply this times 2, which will give us that 14. All right, so once you have the isolated absolute value, you are not done, but this is where you now decide to rewrite it twice. Absolute values have 2 answers, a positive answer. For absolute value of 14 is 14, and absolute value of negative 14 is 14. So you have 2 options. You have x minus 4 could equal 14, and you have x minus 4 could equal negative 14. So when we solve for this, we just follow the same process on both. We add by 4. And we have x equals 18, and x equals negative 12. And in class, I mentioned for you to quickly check your answers before you move on to the next problem. So just plug that in on the original equation. So we're going to type 1/2 absolute value of, instead of x, we're going to put an answer. So 18. And then minus 4 plus 3. And it should equal 10. Oh, I put multiplication, sorry, plus. So it should equal 10. So that confirms that this one is correct. And then now we're going to try negative 12. So we're going to do replacing the 18 with the negative 12. And you get, I got 11. That shouldn't work. Oh, my bad. This should be negative 10. Negative 14 plus 4, it's negative 10. See, caught my mistake. So I'm going to go back and edit and check. If I put negative 10 in there, yes, that gives me positive 10. Okay, so those two are the answers. And then for this next one, we now need to look at this as two parts. So whenever we do the negative version, we need to do a negative into both of these parts. So we're going to have, first of all, are the signs, is the absolute value isolated? So if you notice there's nothing next to this, so yes. After that, we rewrite. So we're going to write 4x minus 1 equals 5x plus 37. And the next one is going to be 4x minus 1 equals negative 5x plus 37. So then we solve. When x's are on both sides, you need to decide which side you want to move the x to. Usually it's to the left side, so I'm going to just go ahead and follow that process. Minus 5x on both sides, plus 1 on both sides. And then 4 minus 5 is negative 1x. 37 plus 1 is 38. Divide by negative 1. So x is negative 38. Over here we have the distribution of the negative first. So it's negative 5x minus 37. And then you're going to move that x to the other side. So add 5x. Move this negative 1 to the other side. So add 1. Cancels and cancels. So we have 9x equals, and this is negative 36. Negative 36 divided by 9. So we get x equals negative 4. Okay, so then now we're going to check our answers. So we're going to plug in that value in there. So absolute value, and there. 4 parentheses, negative 38, minus 1 equals 5 parentheses, negative 38, plus 37. So when I press enter, this comes out as false. And then I'm going to now retype it and press and type negative 4 instead of negative 38. And this one comes out as true. So that means that this is a real solution and this is the extraneous one. So is there an extraneous solution? Yes. Negative 38 is your extraneous solution. Okay, so for the next one, we have similar. This one is also where absolute value is isolated by itself, so then you need to rewrite a positive and negative version of whatever's here. So I'm not going to do this one since it's similar. I'm going to move on to the last example of inequalities. So here it's similar to equations, but we talked in class that when it comes to inequality, we need to rewrite a opposite value, opposite symbol. So here we write exactly what we have as a positive option for the first equation, or inequality, sorry. Then on the other one, we switch the sign and put a 9, negative 9. So just to clarify, you're going to replicate what you did with the equations, but with inequalities, you, of course, first check if the absolute value is isolated. It is. So then we're going to go ahead and move on to writing the expression 1 minus 2x with the inequality of less than and then a 9. And then the other option will be the same expression of 1 minus 2x, but the inequality symbol switches with that negative version of the 9. So when we solve, we just need to remember to flip the sign if we divide by a negative or multiply. So we're going to keep this because we're solving for x. We're going to subtract 1 on both sides. And negative 2x less than 8 is our answer over here. And then negative 2x greater than negative 10. Here we have a division of negative 2 happening to isolate the x. Because we're divided by negative, we're going to flip the sign. And then 8 divided by negative 2 is negative 4. So this is one answer. And then over here is x, flip the sign to less than, and then positive 5. And when you get your answer, you kind of want to sketch what kind of solution set this is. We're going to have negative 4 and 5. X is greater than negative 4. X is less than 5. So we have open circles connected. So this is a conjecture. And the way you're going to write it is just negative 4 less than or equal to, sorry, not equal to, just less than, x less than 5. So this is the notation of this number line graph. All right. For advanced, I'm going to just go over this in class. You don't need to know it for the regulars. So I'll just pause the video here. Hope this review video helps you.